Hello, I am David Ruzick, Illinois Energy Prof on YouTube, and I'm here to tell you how to have plasma fun in your kitchen.
So, you take your grape, you cut it in half. You get to eat the half. Yummy grape. And then, we take this part of the grape, but don't slice it all the way through. Okay? And then we're going to split that grape in half.
Keep it connected.
Yes. Very important. Little bow tie grape. Okay. We're going to put it there. We're going to try the lossy glass, I hope. We'll put it on there. There we go. Oh, we did it!
Look at the top. Getting on the top.
A ball of grape plasma.
Yeah.
Now that was really fun, but the next thing I want to show you that you can do is also very important and useful. So the pandemic hit, and there was these shortages of personal protection equipment. And colleagues and I had the idea, could we do something about that with the stuff everybody has? So then we made this video.
Saw if I could make a plasma with the microwave oven and common household supplies so that this isn't something you have to buy, it's just something you have to do. After getting a plasma, the real key was, does it really kill the viruses? So I found Professor Helen Nguyen here at the University of Illinois. She, her students, and I have worked very hard the last few months in doing viral tests.
And it wasn't just a few tests. I mean, we talked about real grad students, real spectroscopy, multiple tests of viruses inside the mask, outside the mask, sending them off to a government agency for a fit test. And all of this passed, all of this worked. And all this is working its way into the scientific literature. But now I got to show you the fun part, how we actually do it.
Today, I am going to show you how you take common household materials, a microwave oven, and in 30 seconds can decontaminate an N95 respirator. The key is to make an antenna, and the antenna needs to be a multiple number of the wavelengths of a microwave oven. We're going to choose 2. That works pretty well. And since the wavelength is 12.2 centimeters, 24.4 centimeters, about 9 5/8 inches is the amount that you want. And a metal coat hanger, uncoated, works great. Okay, you could do it with any heavy gauge wire. Okay, now I'm going to try to bend this into a loop. Okay. I don't think the precise shape matters all that much, but we're going to try to get it so these 2 ends nearly touch. We're making a split ring resonator. Right, so that looks pretty good. Sometimes I take the very ends here and bend them a little bit because the 2 ends I'm going to want to have touching a piece of ceramic. So let's try that, and then get them just a little bit closer and bend it around. All right, we'll see if that's going to work. The gap here at the end, you want to be between, well, say 1 and 2 millimeters, something like that. What you need next is a ceramic holder, and I have found that a coffee cup works very well. I'm going to turn the coffee cup upside down, and we're going to suspend this, and so sometimes you need a second coffee cup. okay, here, and I'm going to put this kind of sitting like that. Key is that to be able to make a plasma, I'm going to need to add a conducting fluid, and saline solution is an excellent and easily available one. We used a milliliter when we wrote up the paper, you know, not probably too precise. The other key is that to get the right radicals that will kill a lot of the viruses, we use 30% hydrogen peroxide.
3% hydrogen peroxide is fine, all right? At first, we used the much heavier duty pool supply stuff, which is not available in Europe, I learned. And yeah, it killed all the viruses, but we did all the experiments over again with 3%, the common stuff you buy in the store, 2%, 3%, whatever it is you buy in any drugstore, and it works too.
Of this in here, and again, something around 1 milliliter, which is a teaspoon. Okay, I'm going to put on there. All right. Now, need to put this in the microwave. So, after you've done it the first time, you probably just squirt the stuff into the microwave. It's important to disable the rotation. We don't want this to rotate. And I found the easiest way to do that is to just take the big tray and turn it upside down. Okay? So now let's put our cup of solution in here. When you look at a microwave oven, you often see this panel on the side. That's where the microwaves come out. And we want to have this fairly close to where the microwaves come out. At least that seems to work better. This is my other cup, which is just really to support the antenna. And then I put the antenna there, making sure the liquid ends are near each other. I'm just going to get them a little closer. And that both of those ends are in the liquid and touching the cup. You might say, where do you put the mask? Well, the plasma makes radicals. It makes UV, ultraviolet radiation. It makes a whole bunch of stuff that's responsible for killing things. And so we have found that if we suspend the mask somewhere up here near the top, and you can't see, but let me see if I got it taped there. All right, you don't maybe want it right over the plasma because the plasma flares up a bit, but somewhere where I could see the plasma. So that's probably going to work. Now we're ready to make a plasma. So we want to turn this on, say full power, at normal operation. I'm going to put it on for a minute. Hit start. At first, you'll hear some popping sounds as the first liquid starts boiling away. Usually takes about 10 seconds. There we go. You're starting to see little flashes. When we get to where most of the liquid is boiled away, we should go into a sustained plasma mode, which we've done right here. You want the sustained plasma to last for 30 seconds. It was about at 36 or 40 when it started, so we will take this down to about 6. All right. Sometimes the plasma sputters off like that, but that's all right. We're making our UV radiation, we're making our ions and our electrons, and 30 seconds integrated of this beautiful steady state plasma is enough to do it. Well, that was really cool. It was the first time, and
All right, so that is just so amazing, right? You get this bright, glowing plasma right in there. I got to give you a couple safety tips. That wire gets red hot. Do not open it up and grab the wire. You're going to burn yourself. All right? Likewise, the coffee cup. It's just had something that's been red hot sitting on top of it. The coffee cup also gets warm. Don't touch it right away. And one other thing, if you're really using this to sterilize masks, there's a metal piece in the mask. And remember how they say don't put metal in the microwave? Well, that's exactly why, because you can make plasmas after all right? But that strip of metal that holds for the nose, If you left it on the microwave too long, say a couple minutes, it would burn the mask around that metal piece. 30 seconds, it's fine, but just be careful that you don't set your mask on fire. All right? And remember, if you do, the microwave is all metal inside, so turn it off, okay? And if you want to just wait for it to go out, you're probably fine, or get rid of the fire any other normal ways. This is something that is interesting and entertaining, but be careful. And that is what you need to know. And if you want a lot more details, the key is to look at the Energy Prof website, Illinois Energy Prof on YouTube. Lots of cool videos and ones on here that give you much more details, including all of the safety things that you should be very careful about. And I hope here for your mini Science Slam at this conference, the rest of you have a great conference. Bye-bye.